Hi there. Today, I'd like to walk through a possible solution to last week's challenge we posted on our LinkedIn page. Here's a recap of the challenge. We have a series of boxes here represented in blue, red, and green colors. They are 4 meters long slices. And what we want to do here is they follow generally the vein strike orientation. And we want to combine the stopes to make individual stopes with lengths less than 20 meters, not exceeding 20 meters. And in between continuous stopes, we have to leave at least a 4-meter pillar. And the goal here is we want to leave the minimum amount of gold ounces in pillars to maximize our recovery. So here we have some randomly generated gold ounces in these slices here. For example, if I pick these 5 stopes here, then I need to leave this one behind. So that's 11,000 ounces in this one. Of course, that's just some fake numbers we made up. And then we can pick the next group of stopes. Now, how do we find the optimum? That's the challenge. And of course, we simplify the solution here by making them more continuous and more regular shapes. And here, we resorted to ChatGPT for some help, and we got the results back that looks like this. The red represents our pillar selection, and purple are our stopes. And you can see they have also total ounces calculated in Deswik. And I'm just going to walk you through how we solve this challenge. Of course, this is, again, just one possible solution. The idea here is we want to spark some discussions or ideas, hopefully, in your own work, whether you want to learn more about using AI engine to your advantage, or just learn more about Deswik. Here, we resort to ChatGPT first. And then what we did here is we asked this challenge to ChatGPT, describing the situation here very briefly, and say, write me a Deswik macro to do that. The thinking here initially is that I want to solve this entirely within Deswik, and Deswik has macro that could be powerful. I thought of that. So ChatGPT spits out a piece of code with the reasoning. The reasoning totally makes sense to me, so I said, go ahead. This is the code it generates. And I plug the code into Deswik macro. Actually, I'm going to do it here just as a demo. I'm just going to go macro script editor here. And you'll see there's a whole bunch of compilation errors here. That didn't quite work out. Then I didn't give up. I asked ChatGPT to think harder. So I returned all the error messages back to ChatGPT. Still error, error again, error. And then eventually ChatGPT sensed my frustration and said, okay, we're not going to spend more time finessing with the code here. We're just going to use a different approach. So this is what it recommended. Said, okay, we're going to use linear programming. And then I've written a Python code for you. If anyone that's interested, you can look at the entire code on our blog. So this is the code. If you open the code in a kind of a IDE, you can see this is the definition, and then different functions defined. And at the end, there's a main function to look through all the different parameters and then return a optimum results in CSV. So the way it returns CSV is, as explained in here, it asks me to export the CSV file with these attributes and then run the optimizer, and then it spits out a CSV file called stope plan CSV with its pillar, stope ID, stope number, length. And then, of course, you can use some sanity checks here. And then merge the slopes. That's union by attributes. ChatGPT even understands the internal operation of Deswik. So here, pretend I'm someone that didn't even have any prior coding experience, and show me how I can run the Python code step by step. So here's this step-by-step instruction: install, create a folder, open the terminal. So that's what we're gonna do here. We're gonna open that folder in terminal. So we're gonna open in terminal. So this is the terminal. And then we're gonna copy the code here because I didn't give a strike orientation. I'm gonna use this second option here. Copy the code, Control V. And then so basically this is running the Stope Optimizer Python code using solid CSV, which I exported earlier already. And for anyone that's interested to understand how to export CSV, there are different ways. So we just export XYZ as a centroid. So each row represents one slice. And the output is the Stope plan. And there we go. I run that. So now that's complete. And then I'm just gonna open that file here. Stope plan that looks like this. Just as explained by ChatGPT, there are 3 columns here. Is a pillar, Stope ID, Stope length. So I have that. And here, pillar. This is the pillar, so that's not a pillar. This is Stope ID. So these 4 slices belonging to Stope 1, this 5 belonging to Stope 2. So therefore, they have a Stope length of 20. So now, next step is I'm going to bring that information, the computed information, back into Deswik. So I'm going to close the macro. Sorry, it didn't work. By using the import function here, using attributes. So of course you can save the settings if you do this repeatedly. I'm gonna use CSV here. That's the file. Then I'm going to import chain is pillar and Stope length. Next, I'm gonna use the layer of solids, and I'm gonna use the name as a matching key. Finish. Now we got our results back, and then we can see we are gonna show pillar. So that's the results I showed at the beginning of this recording. And then I want to see if this is really optimum. So of course I asked ChatGPT again, see if it can prove that this is the optimum results. So it did provide several solutions to that. One of them is audit trail using this Python piece here. It also provides, alternatives on how you can check that using another program. Here you can use the library PULP, or you can run another ILP, linear programming platform. So for anyone interested in digging into the code, feel free to go and then let me know what you think. But here I'm just gonna do some quick spot checks. What I'm going to do here is I'm going to calculate pillar using a combination of global constants and a formula. So here I'm going to start with every 3 stopes. I'm going to have a slice, and then pillar position is 1. So here, what am I going to compute is basically calculate the index of the stope within the vein, within the same level, and then use the ID. Each stope has an ID. Sorry, each slice has ID. Then return anything that has a mod equal to the pillar position, and then give me the pillar calculation, and calculate the total pillar ounces there. Similarly, I calculate total pillar ounces given by ChatGPT. So I want to run a comparison. So I run the formula, okay, and then I'm gonna visually display my pillars. So every 3. I have a pillar. So you can see I have 11,088 ounces left in pillars. So ChatGPT only got just a little bit over 3,000 in the pillars. So I lost. I'm gonna quickly change the global constants to every 4 stopes. I want to do that and then compute again. Let's see how it looks this time. Pillar 2, so every 4 stopes, I got 4883, and ChatGPT is still 3067. So I lost again. Anyway, that's kind of how ChatGPT has provided me some ideas or solution to this particular engineering problem. Now, of course, the rest is easy. I was gonna union by attributes. So I can run solids and union by attributes, and I can, of course, I'm just gonna select these, and I'm gonna grouping using the is pillar attribute. Where's my is pillar? There. Sorry, I want to merge my stope, so I'm gonna sorry, just I'm gonna use stope ID, and then I'm gonna put it on merged or boolean, so merged. And say okay, and then now it's running some boolean operation. This is a pretty heavy command, so with my computer recording at the same time. Oh, I guess okay, I made a bubble. I'm gonna have to go back and then um, import the stope ID attributes. I didn't check that one. I'm gonna do it again on this. Okay, I'm going to import the attributes, and then this time I'm going to check the stope ID as well. So that's what we're gonna use to boolean, and I will run the union attributes again. I'm gonna select them all and stope ID. So say okay. Okay, now I got these stopes. Oh, I should probably have separate by level. So I'm going to blow this one away. I need to use level and vein to separate them. So union attributes, I'm going to use the concatenation of level and the vein and stope ID. Here we go. I hope this one I didn't mess up. Okay, we have more stopes generated, so it's a little bit slower. I'm gonna, so that is a summary table. I just want to visually check, see if we got our stopes right. Okay, I'm just gonna check. So that's our pillar. That's a stope. That's a stope. That's beautiful. Stope, stope, stope. And then there. That's perfect. So now we got our stopes separated. Uh, We can quickly interactively filter by level and Stope ID. There we go. Okay, so Stope 5, that's our, oh, we have two different veins, so both are Stope 5, and then we have Stope 4. So there, that's our merged Stope. Thank you for watching.